Today's artificial intelligence systems can write complex software from scratch, parse millions of data points in seconds, and pass state bar exams. These systems feel incredibly sharp, but that sophisticated output creates a blind spot. We struggle to tell if the machine is actually thinking or merely executing highly complex calculations. In engineering, you cannot optimize a system if you cannot measure it. Without a concrete way to quantify cognition, developers are essentially flying blind. To pull artificial intelligence out of the realm of science fiction and turn it into a rigorous discipline, early computer scientists needed a tangible metric for intelligence. Back in the 1950s, the scientific community was deadlocked over a seemingly simple question: can machines think? Pioneer Alan Turing stepped into this paralyzing debate. He realized that trying to define thought was an engineering trap. It is a completely subjective internal experience that cannot be verified by an outside observer. Turing's pragmatic solution was to bypass internal philosophy entirely. He proposed focusing exclusively on observable external behavior. By rephrasing the problem from "can machines think" to "can machines convince us it's human," Turing invented the first functional yardstick for computer science. This animated diagram illustrates his proposed setup, known as the imitation game. It requires three isolated people: a human judge, a human responder, and a machine, so not so much a person. The judge communicates with the other two entities, blindly passing messages back and forth using only text. In Turing's day, this meant typing on an electromechanical teleprinter machine. This strictly mechanical interface isolated the conversation, stripping away visual or auditory cues that might bias the human evaluator. The judge has free rein to probe the participants with any topic. They can ask anything from complex math to childhood memories or deep philosophical dilemmas. If, after a set amount of time, the judge cannot reliably identify which participant is the computer, the machine passes the test. This elegant pass or fail setup gave early researchers a concrete target to aim for. You can think of the Turing test as an evaluation of a stage magician. When an illusionist performs a mind-reading trick, they do not possess psychic powers or break the laws of physics. They just construct the setup so convincing that human perception accepts the illusion. Applied to artificial intelligence, the test does not demand that the machine possesses a biological brain or genuine self-awareness. It only requires the system to sustain an operational illusion of humanity during a conversation. This specific target shifted earlier computer science away from building massive machines solely for raw numerical calculation and directed attention toward parsing and generating natural human language. For decades, mastering this conversational stage trick served as the ultimate guiding metric for AI development. Now, skip forward to the present day, modern large language models can routinely fool human judges in short text chats, effectively beating Turing's game. But reaching this finish line has exposed a critical flaw in the benchmark itself. This flowchart demonstrates a concept called pattern matching. Instead of referencing an internal logic module to construct the thought, the AI is generating sentences by calculating the statistical probability of the next word in a sequence. The system operates by mirroring the vast data sets it has trained on. It accurately mimics our conversational flaws and human quirks without possessing any underlying self-awareness to anchor those words. We can now see that the Turing test successfully measured an AI's ability to impersonate a person, but it fell short of measuring genuine intelligence. We are left with a modern paradox. Our machines have perfected the stage magician's trick, yet their circuits remain completely devoid of consciousness. This realization does not diminish Turing's original insight. His benchmark was the vital catalyst that forced engineers to grapple with language processing in the first place. The enduring lesson of his imitation game is that simulating human conversation and actually reasoning like a human are two distinct phenomena. Because our systems have successfully broken the historical measuring stick, researchers must now search for a completely new benchmark to define true intelligence.